Hello, my name is Bhavya. My ID is 24CS004. So we are presenting our concept map on the topic of how advanced routing algorithms address modern network demands such as scalability, congestion, and dynamic traffic. Our map starts from central idea routing algorithms, evolution to meet modern network demands. We divided into four major sections. Uh, Traditional approaches, advanced mechanisms, modern network demands, and trade-offs. So during peer critic, the group suggested that we should add AI-driven routing in the modern section. However, after discussion, we decided not to include it. The reason is that our problem statement focuses mainly on traditional versus modern routing algorithms like DV, LS, OSPF, BGP, and QoS, and multipath. So AI-driven approaches are interesting, but they are beyond of the scope of this problem statement. So instead of adding something outside, we defi we refined our map to stay focused and clear. Thank you.
Hello, my name is Amy Patel and my ID is 24CS059. After the basic, we got a more advanced routing methods. OSPF, Open Shortest Path First. It is a smarter version of a link state. It is a faster and supports area but a more complex. BGP is a huge. It is a basically runs the internet. It can handle 1,000 of routes and allow policies, but it is a bit slow to adjust. Then QoS routing, quality of service routing, came in to give a priority to important things like video calls and voice so they don't lag. And finally, multipath routing lets us use many paths at the same time. These help with a load balancing and reliability, though it harder to manage. These all try to fix the problem of old method and meet today's need. Then the second critique we received was that OSPF and BGP could be seen as a subsection of a hierarchical routing. We agreed with this point because both protocols often rely on hierarchical design to scale efficiency. For example, OSPF divide network into areas with a backbone which is directly follow a hierarchical principle. Similarly, BGP work at an internet backbone level, exchanging the routes between autonomous systems in a hierarchical way. To show this clearly, we added a dotted line between a hierarchical routing and OSPF and BGP. This refinement strengthens our map because it highlights how to advanced protocol don't just replace the traditional ideas but also extend and refine them. In other words, hierarchical routing laid the foundation and OSPF and BGP took it further to meet larger and global scale demand.
My name is Palak Donga and my ID is 24CS020. Today's networks are much larger and more demanding than before, and routing has to keep up with those needs. There are three big challenges. Scalability. With the rise of IoT and cloud networks, they are growing fast. DB can't handle this scale, but BGP and hierarchical routing works better. Congestion. With so much streaming, video call, and online traffic, networks easily get overloaded. QoS routing and multiple routing help to reduce this by giving priority and balancing the load. Dynamic traffic. Traffic patterns keep changing because of mobile users, cloud apps, and shifting workloads. Fast protocols like OSPF and multipath routing adapt much better than older methods. There are always trade-offs. The third critic mentioned that hybrid routing was missing from our modern section. We agreed and added it. Since hybrid routing combines the strength of distance vector and link approaches. For example, EIGRP uses distance vector style matrix but also builds partial topological information, making it more efficient. Finally, in the trade-off section, we highlight that no single protocol is perfect. Distance vector is simple but slow. OSPF is fast but complex, and BGP is scalable but converges slowly. This balance of complexity, convergence, and efficiency is the real story of routing evolution. Through this activity, we learn not just the technical details, but also how to think critically, accept feedback, and refine our ideas. Thank you.